A list is a sequence container like a vector, but optimized for speedy insert and delete operations, and it does not support random access. Here I have a working copy of list.cpp from chapter 10 of the exercise files. Like other containers, a list supports size and front and back. And I'm going to go ahead and build and run here, and we can just look at the output. So here I have my list that I've initialized, and I have size and front and back, and you see the size of the list is 10, the front is 1, and the back is 10. So the front, of course, returns the first element, and the back returns the second element. And so it's easy to access the front and the back of the list, but to access anything inside, the list does not support random access, and it does not support the subscript operator, because it doesn't support random access. And so instead, it provides a bidirectional iterator. So I can push back and actually add something to the end of the list. And so now the size is 11 and the back is 47. And if I use a range-based for loop, I can see all of the elements in the list, 1 through 10, followed by 47 because I pushed back 47. In order to insert and erase, I need to actually loop through the iterators to find the points to insert and erase because it doesn't support random access. I actually have to loop through and look at each of the elements just to find that spot where I want to do an insert or an erase. And so here I want to insert the number 112 before the number 5. And so I have to loop through looking to see if my iterator is pointing at the number 5 or if my iterator has hit the end. And if I have not hit the end, then I go ahead and I insert. And you'll see that I have here insert 112 before 5, and there is my 112 before 5. And if I want to erase the number 7, I have to do the same thing. I iterate through the loop, looking for the number 7 and making sure I haven't hit the end. And then I can call erase on my iterator, and it will erase the number 7. And then you see I printed out and the number 7 is missing. Or I can erase a range. There's an erase that'll take 2 iterators. The erase that takes 2 iterators, it'll erase from the element that the first iterator is pointing at up to the element before the last iterator is pointing. And the reason for that is so that you can use li.end if you want to erase everything up to the end, and it'll erase up to before that second iterator so you don't end up trying to erase past the end of the container. And again, this looks complicated because I'm iterating 2 different iterators here. I have iterator 1 and iterator 2, and I'm looking to see what they're pointing at and that they haven't hit the end, and then I need to test and make sure they didn't hit the end. So the code ends up looking a little bit complicated. The advantage of this is that lists are really, really fast. Doing these inserts and these deletes, even with all of the looping, is a lot faster than it is with something like a vector. So if you have really, really big data structures or data structures that have really, really big elements, then a list can sometimes be efficient. So the STL lists are an excellent choice for situations where you don't need random access and you will be inserting and removing a lot of elements. They're very fast and lean, but at the expense of some functionality.